Although this year the coronavirus has taken centre stage, normally at this time of year in the UK, we'd be thinking a lot about flu. The WHO estimates that up to 650,000 people globally die each year from the flu, and one of the tools in our arsenal against it is the seasonal flu vaccine, where each year scientists make a new vaccine to try and target the specific flu virus that's causing the most damage that year. Last week, however, there was a huge breakthrough in the search for a universal flu vaccine. That is, one vaccine that would give broad protection from lots of different strains of flu, including potentially the ones that cross over from animals like swine or bird flu. I'm Eva Higginbotham, and I spoke to one of the scientists behind the work, Linda Corlin, which was just published in the journal Nature Medicine.
The seasonal vaccines are based predominantly on targeting a protein that's on the surface of the virus called the hemagglutinin, or the HA. So this hemagglutinin protein, it looks like a lollipop. It has a head domain and it has a stalk domain, which is the lollipop stick. And this protein is involved in binding to the surface of cells and getting the virus into cells. It's also a very flashy and sort of attractive to the immune system. So that's what your body will mount an immune response against. And if the vaccine is well matched to the viruses that end up circulating in the flu season, then the vaccine should elicit antibodies that recognize the head of that hemagglutinin, and they should, in theory, be able to prevent that virus from getting into cells and thereby infecting you. So that's all great and all very well, assuming that the vaccines are well matched to what ends up circulating. So sometimes we end up with seasonal vaccines that don't match the virus that's circulating. And that is essentially because we're trying to target this head. When we target the head domain, we can induce strain-specific antibodies, which will protect against the same strain, but they will be very limited in their ability to protect against, a virus that's undergone a lot of mutation.
So what's been the challenge to make a universal vaccine so far?
Flu viruses are very diverse, so that's one problem to begin with. They also infect multiple animal species, but I've described this hemagglutinin protein, or the HA. There are actually 18 different HAs. So trying to find something in common between those 18 HAs has been challenging. And we know from seasonal flu vaccines that the head domain is constantly changing. So obviously this is not an ideal target. So that's sort of what prompted the idea that we should start to look at the stalk domain, or that lollipop stick domain, because it's much more similar between lots of different flu viruses. So the strategy which has been taken in this paper is to make these chimeric hemagglutinins. So essentially what that means is they've chopped the head off the hemagglutinin, and they've put a different head on top. And the idea would be that if you could immunize more than once with a vaccine that has the same stalk or the same lollipop stick each time, so it's identical stalk each time, but you swap out the heads each time, that you could somehow distract your immune system into recognizing this portion of the virus that it normally doesn't pay a lot of attention to. And if you could induce a really good immune response against that particular domain, then you could potentially have a vaccine which induces immune responses in humans that could recognize multiple flu viruses.
So in this study, it's like they took lots of different flavoured lollipops with different coloured heads, but all with the same lollipop stick, and swapped the heads around and gave that to people as a vaccine.
That's essentially exactly what happened. And the idea would be that if you gave more than one immunization, so they call it a prime and a boost immunization, with the same stalk each time, but a different head each time, that you could refocus the immune response towards the part that's in common with each of those immunizations. And the part that would be in common is that stalk domain. I mean, there's been a huge amount of evidence in animal models that this is a very effective strategy. But what this study has done is actually proof of concept to show that you can boost those types of antibody responses in humans.
So essentially, they've seen that this technique, this strategy, produces antibodies against the stalk domain, or rather boosts antibodies against the stalk domain in people who receive the vaccine. How do they know if that is enough for producing an actual immune response, though, if they were hit with a virus? And how long did that effect last?
So that is a great question. And essentially, we have a lot of evidence from animal models that stalk antibodies can protect against diverse influenza viruses. They can, in fact, protect against avian influenza virus, etc. So that is more difficult to test directly in humans because obviously you can't infect humans with avian influenza viruses. But I think the fact that there are extensive studies in animal models confirming that these types of antibodies can protect is very promising and exciting for the potential for it also to behave in this manner in humans. In terms of the duration or the longevity, that's a really important point. And this is a proof of concept study. I believe the antibodies were followed out to 18 months, and it's really great to see that they could detect a durable antibody response out to that time point. But we obviously would need to investigate that further to see how long those antibodies persist, because that's also important. We would ideally like to develop a vaccine that's not only broad, but that elicits long-lasting protection as well. I'm sure subsequent studies will follow on and investigate these things in more detail in the near future.